Introduction to Image Processing and Computer Vision. Image. An image is a two-dimensional function that measures of some characteristics such as brightness or color of a viewed scene. An image can be defined as a two-dimensional function x, y, where x and y are spatial coordinates and amplitude f at any pair of coordinates x, y is called intensity or gray level of the image at that point. An image is a projection of 3D scene into a 2D projection plane. Analog image. It is characterized by physical magnitude varying continuously in space. When x and y and amplitude values of f are continuous quantities, the images are analog. It cannot be broken into small individual pieces. Represented as continuous range of values representing position and intensity. Digital image. When x, y and amplitude values of f are all finite, discrete quantities, the image is digital. It is composed by picture elements which are called pixels. Pixels are the simplest form of an image. Pixels are used to represent brightness of an image. Conversion of analog image into digital image. Conversion of analog into digital images involves two important operations. These are sampling and quantization. Advantages of digital images. The processing of an image is fast and cost-effective. It can be easily stored and efficiently transmitted from one place to another. Copying of digital image is easy. The image would not be degraded even if copied several times. Reproduction of digital image is faster and cheaper. Drawbacks of a digital image. Anyone can misuse images by abusing copyright of images. Digital images cannot be enlarged. Memory is required to store good quality of images. Digital image processing. Processing of digital images by computers. Image is composed of finite number of elements. The image of the object is captured in the imaging system in the form of transparency or photograph. The digitizer is used to convert original image to digital image by using sampling and quantization. It is then stored in computer memory. The images are displayed through television monitor. A mini computer may be used to communicate and control digitizer, storage, etc. The program inputs to the computer are made through a terminal and outputs are also available on a terminal. Computer vision. This is a branch of artificial intelligence and image processing concerned with computer processing of images from real world. Computer vision typically requires a combination of low-level image processing to enhance the image quality and high-level pattern recognition and image understanding to recognize features present in the image. Advantages of processing images by computers. Flexibility and adaptability. When compared to analog electronics and optical information processing, no hardware modifications are necessary in order to reprogram digital computers to solve different tasks. Digital computers are ideal devices for processing image signals adaptively. Data storage and transmission. Development of image compression data can be effectively stored. Digital data can be easily transmitted from one place to another. Digital image representation. Two-dimensional discrete signals. It has n star n elements. Each element in the array is a number which represents a sampled intensity. Converting image into digital image can be done by using digital camera and scanner. Digital images can be created directly on a computer screen. It is restricted in spatial coordinates, sampling, and allowed in intensities, quantization. 3 types of image processing: low-level image processing, mid-level image processing, high-level image processing. Please view the diagram. Low-level image processing. It is characterized by the fact that both its output and inputs are images. Example: noise removal, used to remove noise from an original image. Contrast enhancement, used to improve quality of an image. Image sharpening, highlights the edge of an image. Mid-level image processing. It is characterized by the fact that its inputs are generally images, but its output are attributes extracted from images, such as segmentation. Example: image classification. Assign a label to an object. Image segmentation, used to partition an image. High-level image processing. It is characterized by the fact that its inputs are attributes extracted from images and outputs are generally images. It involves object recognition and image analysis. Example: scene understanding, autonomous navigation. Please view the diagram. Origins of digital image processing. One of the first applications in digital image processing was in the newspaper industry when pictures were first sent by submarine cables between London and New York. Pictures were coded for cable transfer and reconstructed at the receiver end on a telegraph printer. Introduction to Barth-Lane cable picture transmission system in 1920 reduced the time required to transport a picture across the Atlantic from more than a week to less than 3 hours. Specialized printing equipment was used to code pictures for transmitting via cable and then reconstruct the image from the code at the receiving end. In 1964, computers were developed to improve quality of images of Moon taken by the Ranger 7 probe. In 1970, digital image processing began to be used in the medical field. In 1979, Godfrey and Cormack shared the Nobel Prize for inventing medicine for tomography behind computerized axial tomography scans. Since 1980, digital signal processing is used in many fields like industrial, medical, military applications, etc. Digital image processing application areas: improvement of pictorial information for human interpretation, processing of image data for storage, transmission and representation for autonomous machine perception. Advantages of DIP. It improves visual quality of an image. It can easily process degraded images of uncoverable objects. It can process an image in such a way that the result is more suitable than the original image. Image compression technique can be used to reduce the amount of data which is required to represent a digital image. Mathematical and logical operations are performed on an image like addition or multiplication, etc. Image segmentation can be used to detect discontinuity, the presence and absence of specific anomalies like missing components or broken connection path. Limitations of DIP. It requires much storage and power for processing. Effect of environmental conditions may degrade image quality. Segmentation of non-trivial image is one of the most difficult tasks in digital image processing. Applications of digital image processing: gamma ray imaging, X-ray imaging, imaging in ultraviolet band, imaging in the visible and infrared bands, imaging in the microwave band, imaging in radio band. Gamma ray imaging. Images based on gamma rays include applications in nuclear medicine and astronomical observations. In nuclear medicine, a patient is injected with a radioactive isotope that emits gamma rays as it decays. Images are produced from this emission and are collected by gamma ray detectors. Positron emission tomography. This is another modality for nuclear imaging. When a positron meets an electron, both annihilated and gamma rays are given off. These are detected and tomography images are created using principles of tomography. X-ray imaging. Oldest sources of EM radiation used for imaging. X-ray used in medical field and other industrial areas like astronomy. In digital radiography, digital images can be obtained by following two methods: by digitizing X-ray films, by having X-rays that pass through a patient and fall onto a device such as a phosphor screen that converts X-ray into light. Imaging in ultraviolet band. It includes lithography, industrial inspections, microscopy and lasers, biological imaging, and astronomical observations. It is used in fluorescence microscopy, which is one of the fastest growing fields in microscopy. Imaging in the visible and infrared bands. The infrared band is used in conjunction with visual imaging. It is also used in visual processing and remote sensing. Imaging in microwave band. Radar is the application of microwave imaging. Its unique ability is to collect data over virtually any region at any time without regarding the weather or ambient light conditions. Imaging in radio band. Radio band imaging is used in medical and astronomy fields. In medicine, radio waves are used in MRI, magnetic resonance imaging. It places a patient in a powerful magnetic field and passes radio waves through the body in short pulses. Ultrasound images. Used to determine development of health. Ultrasound waves are generated using the following procedure. Ultrasound system transmits a high-frequency sound pulse into the body, usually at 1 to 5 MHz. The sound wave travels through the body and hits the boundary between tissues. Some of the waves are reflected back to the probe and relayed to the computer. The machine calculates the distance between the probe and boundaries by using the speed of sound and time required for each echo to return. The system displays the intensities and distance of the image displayed on a screen, forming a two-dimensional image. Transmission electron microscopy. Transmission electron microscopy, TEM, is a microscopy technique in which a beam of electrons is transmitted through an ultra-thin specimen, interacting with the specimen as it passes through. The image is formed from electrons passing through the specimen. The image is magnified and focused onto an imaging device, such as a fluorescent screen on a layer of photographic film. TEMs are capable of imaging at a significantly higher resolution than light microscopes. TEMs are used in many applications like cancer research, virology, material science, as well as in pollution control, nanotechnology, and semiconductor research. A TEM image of poliovirus is shown on the screen. A poliovirus is 30 nm in size. Scanning electron microscope. Electron microscope that produces images of a sample by scanning it with a focused beam of electrons. The electrons interact with atoms in the sample, producing various signals that can be detected about sample surface topography and composition. SEM can achieve resolutions better than 1 nanometer. Specimens can be observed in high vacuum, low vacuum, and wet conditions, and at a wide range of cryogenic conditions. These pollen grains taken on an SEM show the characteristic depth of field of SEM micrographs.